Now the topic is population problems of mapping. The population mapping is the presentation of numerical information related to the population in two-dimensional surface with reference to its geographical space. Okay, here three things is very clear. Presentation of numerical information. Second thing is that presentation in the two-dimensional surface rather plain paper. And third is the plotting in reference to the geographical space. Mainly population density, population sex composition, gender composition are plotted on the map. Normally choropleth method, isopleth method, dot and sphere method, and the proportional circle, proportional square, proportional pi. Those methods are very popular in the mapping techniques of population. Very recently, GIS-based computer mapping techniques, it's very sophisticated techniques. Researcher, individuals, group of researchers are using that techniques. But few problems are already noticed by the researcher and individuals or the group of individuals related to plotting of population data on map. Because in map plotting related to the geographical space, first problem is that population data is not 100% error free. Most of the cases are population data collected from the primary source, and most of the cases this data is not 100% error. Second thing is very vital. Population data and the spatial variation of population attributes is very common. So, so go through this map. This is the sex ratio of West Bengal. Here, sex ratio has been plotted in reference to the district boundary. So, this method, district boundary and the sex ratio coincide. But within the same district, suppose it's a Bankura district and here the sex ratio is 972, 995. But this sex ratio is not uniformly distributed throughout the district. So, but this sex ratio is not uniformly distributed through the whole district. Therefore, the special reference that merge with the political boundary somehow it provides the erroneous information regarding the sex ratio of West Bengal. Suppose it's a Darjeeling district, here the sex ratio also 972 or 5995. But throughout the whole district, the sex ratio is never ever been uniformly distributed. But here the special attributes of population mapping techniques merge with the political boundary, merge with the administrative boundary. That's why it provides the erroneous result. Second thing is that suppose this is the map of India and showing the gender gap in literacy rate by the district of in India. This is the based on the census of 2001. But here also the gender gap in literacy ratio described or described rather shows in the spatial variation. Throughout the whole Rajasthan, the literacy rate is not really uniformly distributed. Or throughout the Jammu Kashmir region, the literacy rate is not uniformly distributed at the rate of 13.7 to 23. So spatial variation is a problem in population data. Rather, population information in mapping or in plotting in the map provides a erroneous result. And third one is the proportional circle. Suppose this map showing the proportional circle of the Birbhum district of total population. Suppose this circle is big one. Okay, that means this block contain the larger population than this one and this one. But this population density is not uniformly distributed throughout the block boundary, throughout the whole block. That's why it's provided concentrated information. So it's very difficult to describe, to depict, to show the population, to show the population data within the administrative or the political boundary. And another thing is that, okay, this is the another map. This is the dot method, choropleth method, and isopleth method. Isopleth method is not really applicable for the population mapping, because if if student or researcher go through the rainfall region or the agriculture region, then he or she can identify the region on the basis of line of uniform distribution. But population is never ever been uniformly distribution throughout the line and zone. So to depict the population, to show the population data through the isopleth map is not error free. And another thing is that dot and sphere method. Here the Amaravati district showing the population and distribution through the dot and sphere method. Here problem is same. Uh, it's not properly showing the whole distribution or regional variation or the variation within the block of the population densities on all these things. So, and even the dot, even the choropleth method providing the showing the is showing the same problem. Therefore, this map showing the literacy rate, and literacy rate merge with the administrative or the state boundary. But it's not true that literacy rate of West Bengal always throughout the West Bengal varies from 70 to 80%. But within the West Bengal, there are few states are backward state, suppose Bankura, Purulia, and Mednapur. Within the backward state, there is a variation of rural and urban areas and remote rural areas. Throughout the remote rural areas and the urban areas, throughout the district or throughout the state, population is not uniformly distributed in the 75 to 80%. So it's a problem to describe, to show all this information, all this numerical information related to the population in in the isopleth or choropleth or other techniques. Okay. And third is that I have told that poor medium choropleth isopleth method is a very poor medium for the presentation of population based data. And same problem is related to the choropleth mapping techniques. Okay, now basic thing is that data relating to the physical environment such as soil, vegetation, agriculture may be mapped using their natural boundaries or political boundary. But in the cases of population data, it's a real problem because data is centroid data set, and population data set is a centroid data set, because if we depict the population data in through the method of dot sphere or choropleth, all these things, or the isopleth, then the real representation of reality is not properly sourced through the mapping techniques because of data sets centered in a particular place, not uniformly distributed. Okay, that's called centroid data. And another thing is that a few computer modeling techniques has been used, but problem is same in the even in the sophisticated GIS techniques, because population distribution sometimes within the same city, population distribution or population density is more along the roadside, along the marketplace. Within the same city, within a 2 kilometers or 3 kilometer area, population density varies. That variation not clearly described or not clearly shows by the mapping techniques. That's why a few statistical techniques has been used to describe, and few index method has been used to describe the population instead of population map.